Cylinders and quadric surfaces. In this video, the goal is not to show you all the different quadric surfaces and all the different cylinders and things that we could draw, but instead is intended to give you techniques that you can use to draw all sorts of different surfaces in three-dimensional space. So let's look at our first surface, which is x squared plus y squared equals 1. And notice that this is a circle in the xy plane that is centered at 0, 0 and has a radius of 1. So let me draw a circle in the xy plane centered at the origin, or at xy equals 0, 0, that has a radius of 1. And it'll look something like this. Now, what I said isn't completely true, because recall that in three-dimensional space, x, y, z in this case, where one of the variables is missing, it is implied that the other variable is true for all real numbers and includes all real numbers. So I don't simply have a circle at z equals 0. I have a circle centered about the z-axis for every value of z, where all of these circles have a radius of 1. So something like this, as well as below the xy plane. And so this equation here is a circle in two-dimensional space, but it is a cylinder in three-dimensional space, centered about the z-axis. Let's talk now about a technique I use, probably the most common technique I use when I'm trying to draw in three-dimensional space. And I use something called a trace. And let's consider the equation x squared plus y squared over 9 plus z squared over 4 equals 1. So a trace is when we hold one variable constant. Almost always, or very often, we set that one variable equal to 0. And then we draw the two-dimensional shape in the leftover or corresponding planes for the other two variables. What do I mean by that? Well, let's let z equal 0. And we're going to do the trace in what's called the xy plane. So when z equals 0, right, we're in the xy plane, and that leaves us the equation x squared plus y squared over 9 equals 1. And we know that to be an ellipse centered at the origin in the xy plane. That's going to go out 1 on the x-axis and then 3 on the y-axis. And so in the xy plane, we have this ellipse. Something that looks like this. Okay, what about if we let y equal 0? So we let y equal 0, we're going to be in the xz plane. And when y equals 0, we get the equation x squared plus z squared over 4 equals 1, which is an ellipse that goes out 1 on the x-axis, but goes 2 in the z direction. So we could draw an ellipse that looks sort of like this. And that ellipse is in the xz plane. Finally, I'm going to let x equal 0, which leaves us with y squared over 9 plus z squared over 4 equals 1, which is going to be an ellipse in the yz plane, where we go 3 on the y direction and then 2 in the z direction. And so basically we're just connecting or kind of finishing off our graph. Something like this. Now, I could draw more ellipses at different heights. I'm just going to add like one over here just to kind of get the feel of what's happening, and maybe one over here to get the feel of what's happening. But basically, once you have two or three, maybe you want them all, you just kind of connect the dots and imagine what the rest of the shape would look like. Notice that every shape is an ellipse. So this is something that's going to be called an ellipsoid. But it's using traces, specifically x, y, and z respectively equal 0 to get the shape. I'm going to do a different type of trace on this next equation. Let's let z squared equal x squared plus y squared. Now what does that equal? So in this case, I'm going to find z for different values. Meaning if z equals 0, we get x squared plus y squared equals 0. These also could be called level curves. We'll use that term later on. But when z equals 0 in the xy plane, we basically have a circle whose radius is 0. That is, we just have the point 0, 0, 0. What about when we have the height z equals 1? Well, at the height z equals 1, we have the equation x squared plus y squared equals 1, which is a circle with radius 1 centered about the z-axis. So something along these lines. How about at the height z equals 2? Well, we have another circle, x squared plus y squared equals z squared, or 4. So at the height z equals 2, we have a circle now that has a radius of 2. And I think you see what's happening. When z equals 3, we have a circle with with radius of 3. And then if I connect these circles on the outside like this, we see that we get a cone. Similarly, if we were to do z equals negative 1, we would get x squared plus y squared equals positive 1. So we would get a circle with radius 1 centered about the z-axis, but when z equals negative 1. And so without doing all the detail, I already know what's going to happen. I'm going to get a cone centered about the z-axis, but below the xy plane, just like that. How about this one? What if z equals, say, 9 minus x squared minus y squared, but z is also greater than or equal to 0? What do you think this would look like? I'll get my x, y, z in here. Remember that the solid lines we consider to be the positive axis and the dashed lines be the negative axis. Not that we needed it here. So let's take a look at this part. If z is greater than or equal to 0, I know everything, if there's anything, will be above the xy plane. So let's do the one where we have, let's say, z equals 9. That is, we'll find some level curve type traces. So when z equals 9, we get 9 equals 9 minus, and watch this, x squared plus y squared. Here's one way to handle it. What is the only way we could get this to be a true statement? Well, the only way this is a true statement is when x and y are both 0. So when z equals 9, x and y are both 0. So we have the point right there above the point 0, 0 in the xy plane, and z equals 9. All right, let's do some other traces now. Let's do the one where we let x equals 0. So if x equals 0, we have the equation z equals 9 minus y squared. Now, what kind of shape is that? Well, hopefully you recognize that as a parabola. So in the zy plane, we have a parabola that'll look something like this. That's in the zy plane, right? How do I know that it goes 3 to negative 3? Because here z equals 0 implies y squared equals 9, and so y is 3 or negative 3. Similarly, let's let y equal 0. And of course, that'll give us z equals 9 minus x squared. So we will have a parabola in the xz plane that goes out 3 in that direction. Okay, one more. What if z equals 0? Now, I already know what it's going to look like in the xy plane, but just in case you weren't sure, we're going to let z equals 0, and that's going to give us the equation 0 equals 9 minus x squared minus y squared, or similarly, x squared plus y squared equals 9. So in the xy plane, we have a circle centered at the origin whose radius is 3. So we have a shape. It's limited because of this back part 0 greater than or equal to 0. But the traces in the yz and xz planes are parabolas. So this shape we would call a paraboloid. Another approach just to show you on this one, instead of doing these traces like I did, x equals 0, y equals 0, and z equals 0, I could have done other traces like I started with. For example, what if I let z equal 5? So if z equals 5, we would end up with 5 equals 9 minus x squared minus y squared, or x squared plus y squared equals 4. So when z equals 5, we would have a circle centered about the z-axis with a radius of 2. So we could have done something like this, but whatever way or approach you like, whether doing this level curve approach or doing kind of a trace approach, usually with x, y, and z equals 0, you should have techniques now that you can use to draw surfaces in three-dimensional space.